between screen sharing here and screen sharing here. It's just not fast. So what is the experience like between the two lessons? How does each one make you feel? Or how does it potentially, how does it make kids feel? And I really would like to hear your thoughts, whether or not you actually teach calculus or not. And basically, you know, how are the two lessons alike and how are they different? So I would invite you to unmute and share your thoughts.
I mean, I can get the discussion started. The tax one is basically the classical way of integrating a function using numerical method. In this case, they were using Riemann sum, which one could call trapezoidal method, basically trying to approximate the area under the curve and doing it analytically, but as well as numerically. On tax 2, the use of decimal made it very dynamic in terms of doing similar thing, finding the area under the curve, which is numerical method of integrating a function. And you can see, especially, I'm not sure which slide this is. This is slide number 4. You can see the approximation as n is sliced more up to 89. The approximation become more accurate than when you sliced it to 32 or even 12. So that is very dynamic. It will help the learning to be enduring as well as visual as per what is happening as you are slicing those rectangle or triangle in some cases.
Great, and lots of amazing comments in the chat window as well about you know, task 1 being a read and learn, task 2 is inquire, interact. Grace says task 1 is the way to teach before invention of the internet, and task 1 is heavy on notation, while 2 uses basic geometry to understand the concept. What about the context? You know how?
Yeah, can I talk a little bit? So the first one, just introduction about integral. So give the students an idea how to find the area below the curve using the function. And second one, apply the concept of integral into real application in such as physics, because in general we know a lot of students know when the velocity is constant, that'll be easy to find the area because it's a rectangle, the length times width. But in case that the velocity is not constant, we have acceleration, and then therefore the curve is not a horizontal, so therefore it's a curve. And then in general, so physics, or maybe AP physics, because I'm also teaching physics. So the concept of the displacement, not velocity, and not distance, displacement is the product of the velocity times the time. So if you cut the time tiny, so that's also the rectangles add them together. So therefore, if kids are taking both AP calculus and AP physics, so they know, oh, they are kind of related. So in general, you can solve using calculus to solve any physics problems.
Thank you. Thank you for sharing that. What else? What other noticings did you have about the two activities? Let me share my screen again. Am I sharing the right thing? No. I'm trying to find the right thing to share.
I think just even in general, like how the Desmos activity starts, it can connect with a lot of teenagers. For example, I personally know a lot that have talked about wanting to go to Coachella. So like immediately they already like know the context and are interested in how it connects to like what we're going to teach them.
Great, thank you. Now, here's the thing. When you come into this particular activity, the context was a family reunion and a picnic. wouldn't that be relatable to kids as well?
Well, I think here it's the idea of just putting something into, you know, just briefly. So, oh, I did this, so it relates to kids versus making it more interactive. I think the idea is that really the equity part is the interactivity, then just sticking something at the start and saying, oh, it's your cousin.
It's wonderful insight. Thank you so much. And you know, not that this is a calculus lesson today. We're not doing a calculus lesson. What about the progression of learning that's happening here from slide to slide? And Philip already alluded to this, right? That this idea that you can play with the rectangles, right? And see how accurate it becomes. And then ultimately expanding to this idea of displacement, whereas over here, it's just in the first quadrant. So this is, and using speed as opposed to velocity. Those of you who teach calculus, the distinction, of course, is this is distance versus displacement. And displacement, of course, can have, depending on your A and B values, you can have negative values, right? So anyway, I think you folks have nailed some of the key ideas here. This is really where I wanted to start, by addressing the idea of what is equity and how do we promote equity in our teaching. And I love what Jeffrey just said just a second ago. Let me go back to sharing. Again, this is the limitation of having one screen. I have to toggle between windows and let's see here. Here we go. The idea is that prior to the oh, and then somebody else shared this, I think maybe it was Grace. Prior to the pandemic, we taught this way, or a lot of teachers did, right? It was about information dissemination. I call that teaching 1.0. It's basically the teachers telling kids how to get the answers. Here's how you do it, kids. Copy this down and let's practice. And then teaching 2.0 was emerging in the past couple of decades, and Philip and I know this really well as coaches. We were teaching kids to learn how to fish, right? 1.0 is just feeding them the fish. 2.0 is teaching them how to fish. So basically, we were trying to facilitate reasoning and sense making. But what teaching 3.0 is, what I'm getting at, is what emerged because of the pandemic. And here's why. If kids really cared about Riemann sums, if kids really wanted to know the area under a curve, if kids really want to know how to play guitar, if kids really want to know how to play Fortnite, they don't need us. They really don't. We have the internet. And before the internet, they kind of needed us. But with the internet, if they want to know how to solve a system of equations, they don't need us. They can just look up Khan Academy. They can go to YouTube, anything they want. You know, if they really, really wanted to know how to find the derivative of something, not that kids on their own care about that, but if they did, they can look it up. They don't need us. So what our job now is to really motivate them to want to learn. That's the key. Teaching 3.0 post-quarantine is all about motivating the kids, because if they're not motivated, they're just going to sit in your class. You know that. They're not going to do any work. They're just going to sit there. And there are kids, you can cajole them, you can bribe them, you can be nice to them, you can call home, you can do all those things. But if they don't want to do it, they're not going to do it. If they want to do it, they'll spend all night doing it. You can't stop them. It all comes down to motivation. So the key really in this day and age, in this teaching 3.0 era, is motivating kids with the math that we love, right? And you know, some of this stuff is fascinating. It is just delightful. It is useful. They don't know that, but you have to convince them. And this is what equity begins with. If you can't get all the kids interested, then only a few kids are benefiting from your instruction. And so equity means we have to pay attention to how to get more kids on board. thoughts and responses to that? What's your classroom like right now? Are kids generally motivated? Do you have half the kids tuning out? What's happening?
We've got, I would say that we've definitely got some unmotivated kids because they feel the frustration of their lack of success in math.
Mhm.
But just want to add that how you just presented like the motivation part, I found that to be really good, really refreshing. You just kind of spoke to equity and under such a different light, and it was really good. I just enjoyed it, by the way.
Thank you, Tanya.
Yeah.
Other thoughts about your kids right now in your classroom? What percentage of kids are we losing?
I think this year has been kind of difficult for the students, even just coming back, because I noticed during this time, a lot of my seniors will be into, oh, what college am I going to apply to? I'm going to do this, I'm going to do that. And this year, I see a lot of self-doubt. I had students tell me, you know what, I don't even think I'm going to college. I don't even think I'm good enough. I'm going to do well. And these are students who do fairly well. So if these students are feeling that way, how's everyone else feeling? And I
Right.
think that's when sometimes, I have to like kind of put the math away and just have a just have a real talk with the classroom, because if they're not feeling, like they can do it, then, and they're not really into it. And if they don't see like a goal, then, they're not going to really be paying attention anyway. But I have seen like more students now have a lot of self-doubt, and, and they don't really know how they're feeling about anything. And I think even as teachers right now, we don't know how we're feeling half the time either.
Excellent point, Carmen. During the pandemic, when we were under quarantine, I know something happened to me, and maybe many of you too, is you reevaluated what really mattered, what was important, and what's not so important. What are the things that you really treasure, family, loved ones, whatever? And kids did the same thing. They're at home rethinking, and maybe not to the level of insight as you as adults, but they're rethinking what they cared about and what they didn't care about. And truth be told, and maybe not the calculus or TCMS kids, but your other classes, your Algebra 1, Math 1 classes, a lot of those kids don't really like math. They don't really care about math. That's not their thing. And so because the pandemic has really forced us to reevaluate what we value, math may fall low on their list of things to care about. And of course, it shows up in classes, apathy and whatnot. So to that point, most kids don't love math the way you love math. And they certainly don't love it the way it's presented in most textbooks. And what is taught in a math class really shouldn't be seen as an end in itself, but a means to an end. And that's the beauty of TCMS, right? TCMS is all about math with a purpose, as opposed to math just because we said so, or because it's going to be on SBAC. Like,
so Ivan, I know you asked how many kids are we losing? I just received data, district-wide data. In the chat, I put in the aggregate for the whole district. So about 40% of our kids are failing either D or F. And also that translates to a huge number when you look at what we have there. So we're losing about 30,000 kids are not doing well.
That is heartbreaking.
And this is for high school. The number is similar for middle school.
Oh my gosh.
I'd like to share with you about motivation. So this is the end of semester. So we were told to give students multiple choices to retake the quizzes or make up their work. So that's why I came up with the idea for Excel assignments. I gave them chance to make up the work that missed for the previous weeks. And just a few students took the opportunity. They didn't want to do anything more.
Even when they had this chance to improve their grade, they didn't take it. Is that right?
Yes, and I provided weekly tutoring and just just 1 or 2 or less than 5 students to that opportunity to to get tutoring.
Right. Because you know what, at this stage, grades just don't have the same effect anymore. We cared about grades, right? And the kids who want to go to college, they care about grades. But a lot of kids are saying, I don't want to go to college. I'll make my money making TikTok videos. And so college is not even something they even think is a thing for them until maybe later in their lives. But right now, and that's the reason why they don't care. So my thinking here is that we need to convince them that math is not just a collection of these topics that they have to pass on a test, because kids don't care about grades anymore. That's the problem. The kids who care, they're fine, but it's fewer and fewer. As Philip pointed out in the chat, we're losing a lot more kids every day. So what we want to do is to convince kids and show them that math is a tool that they could use to make sense of the world around them through quantities, relationships, and representations, right? That it's a tool, not a bunch of topics, just so that they can pass a test. And I love that TCMS's statistics is so much better. And thank you, David, for sharing that, even though the transition is difficult, the kinds of investigative lessons are probably making a difference with your kids. So what I want to do is to illustrate what it means to motivate kids and to use math in a sort of a different kind of way. Math, not for its own sake, but math for an immediate purpose, not even for mathematical purposes, but just an immediate purpose. So I'd like to go to this link right here, tinyurl.com, secret slope. Now, you know what it is. This is meant for kids who don't know what it is. So I invite you to go there and think about what students would be doing in the activity. We're going to unpack it and figure out what kids are being asked to do. So go ahead and play with this one real quick.
If I might make just a brief comment.
Yes, please.
Math is a means to an end, but it's also amazing in and of itself. And when we teach math, if we are feeling that connection with the math itself, it's amazing. I mean, you can't see a number, right? But yet it's there, and there's so many amazing things about how math works. If we feel our enthusiasm about it while we're teaching it, that can be conveyed. And so there's also not just about what it does for us, but that's an aspect of the universe that's amazing in and of itself. And if we experience that while we're teaching, I think we can, some students can hopefully pick that up. So that's also another aspect I wanted to mention.
Absolutely. And that's you, right? You bring that to the room. Your love, your enthusiasm, your appreciation of math is what will translate to kids. Sometimes they don't care on their own. My point is, on their own, they may not have that love the way you have, but because you bring it to the classroom, it then transfers over to them because the kids feel it. And that's the same thing we experience when we go to a concert, right? We feel the performance and it becomes part of us as well. And it inspires us. So I just thank you so much for bringing that up. It's us that's inspiring the kids. We have to motivate the kids.
At the same time, I totally agree with Jeffrey. And we do that, or we try to do that. We make our attempts to inspire the kids and spark their interest in the classroom all the time. But the point that Ivan was trying to bring in, I mean, like during the pandemic, everything was turned upside down, and who cares about the area under the curve, while as we have to go on survival mode. So I would love to see what Ivan has to say about how to make this math practical and practical, related to current situation where this interest of math is just diminishing, because the technical stuff at this point really goes out the window for the kids. So I'm really open for the idea.
Well, I'm excited to be able to kind of bring to you some strategies that will actually save you time, I hope, and get better results and get that motivation. So go ahead and go to this screen, the secret slope, and I want to have you play with it a little bit and see what comes up here. Let me go there myself. I should have had it open already, but let me share my screen. So hopefully you're already there and playing. This is just my home screen. So this is the activity I just shared with you, and it's short and sweet. So you all know the answer, okay? But put yourself in the shoes of a kid who doesn't know. So it's in their mind, it's not even about slope right now. So the question is, what's the secret number? So they get to drag this anywhere they want, move it around, do whatever they want. So I'm going to just type in a number. You're doing the same thing, but you can do your own thing. See, I know you're all teachers. You're going to get it right. But kids might not know. So they'll just randomly guess a number and it'll say, nope, that's not it. So maybe they'll try a different number, so they'll go bigger. Because remember, these are kids who don't know. Okay, so 2 didn't work, so I'll go 1/2. Let's see if that works. Still not it. And now I've run out of guesses. So then we pause. Okay, kids, what would make it easier for you? What additional information would be useful? So talk to your neighbor. Let's do this as a class, right? We can talk about it, or just the prompt is there, the kid's working independently. Any one of those configurations. So you go to the next screen, it's the same thing, but now you've got some additional information, and notice the secret number, we'll call it secret number for now, shows up. No matter where you put it, it shows up. What's going on here, right? And the question is, where do these numbers come from? So there's some clues. Where did the 4 come from? Where did the 5 come from? And so the student might say, well, 4 is half of 8. And 5 is this number over here. So I take half of this number and I use this number. That's my hypothesis. So then the question is, well, try again. Does that hypothesis work? Okay, I'm going to do, remember earlier I said it was half of that number. So I'm going to do it over here. So is this half of this number and this number? So is it 3/5? No, it's not 3/5 anymore. So you can see where this is what's happening here, right? Kids are playing with this. And then they basically test their hypothesis. Okay, so now you think you know, type in what you think the secret number is. And so they said, okay, I think it's going to be add the top 2, so that's 15, and then add the bottom 2, that's 8. I think it's 15/8. And that's not it. So again, their hypothesis didn't work. So they have to revise their thinking. So, okay, adding those didn't work. Do I subtract them? So basically the kids, you can see, are playing around until finally in their groups, in discussion, in whatever way you facilitate this, they come to realize, and you all know the punchline already, right? You know what the answer is, that you subtract the Y values and you subtract the X values. So now they have a textbook problem that they get to create themselves, make it as easy as hard as they want, and then they can put in their answer. And now they know, right? It's going to be 5/9. And that is correct. And that's called slope, kids. So now the kids have learned the slope formula, the y2 minus y1 over x2 minus x1. And so in this manner right here, in 4 short slides, the kids can actually learn this formula. Now, pause for a second. How many of you have taught the slope formula in one of your classes in the past?
All of us, yeah.
How long did it take for the kids to master the slope formula? In your experience, how long did it take your kids to master it?
Well, the thing is, Ivan, like if we give them the conclusion up front, it takes, the practices, and it takes different kind of levels of effort to master it. Some kids with the little effort they can, some more. Bottom line is that the retention sometimes goes away quickly. But I see a point here. If you give the students opportunity to hypothesize and investigate, then their different modality of learning ability gets enticed and it gets tested. Therefore, that you go through a certain experience that becomes part of your long-term memory.
Mhm.
The idea, I think, is very noble. Yeah, I think it's very practical as well. Yeah.
So to build on your point, brain research tells us that there's two kinds of learning that occur. The kind of learning that happens when you are just passively receiving, copying down notes, listening to your teacher, is very different than the kind of learning that's generated by the kids figuring it out on their own. But with support, right? You can't just have kids or expect kids to just on their own figure out everything on their own. Structure has to be provided so that you're kind of guiding them. And this is what Otelia was mentioning earlier, this idea of guided discovery. So they're discovering, they think they're discovering, but you set it all up so that they actually are guided to make that discovery, but they own it. It's theirs. And that retention, like you just said, is much, much stronger. And the kids will remember a lot better when they do it in that way. Thank you for that comment. Other thoughts? Other ideas that are going through your head right now?
I would say
Yes.
most of the kids, they are used to show and tell, and they wait for you to give an answer. Even though right now we are on the, no, you said teaching 3.0, we use technology, but they are still waiting for you to give an answer. They, you know.
Yes, that is very true. You know why that's the case? Because they think that's what math is. They think math is about the answer. Notice in the secret slope activity, I gave them the answer. So when they move the points, the answer is there. The slope is there. The question is, how do you get that answer? That's the real learning, not what the answer is. It's how do you get there? So the hypothesizing is really, I already know the answer. That's not even the issue anymore. And by the way, if the kids get it wrong, there's no shame. Think about that for a second. When you ask kids to answer in class, how many kids raise their hands and actually answer? Only the ones who know how to do it. The rest of them will sit there and be quiet. And the problem there is because they feel like, I don't know the answer, so somebody else is going to answer it. And in their mind, and this is a really good point here that you raised, in their mind, learning math is about learning the answer, like what's the answer? Whereas in this instance with Teaching 3.0, the answer is secondary because you can look it up. You can, if you want to know the answer to a complex, even integration by parts problem, you can look that up. Wolfram Alpha, Photomath, all these apps are out there. The answer is very cheap these days. It's really how do you get the answer that's valuable, because that's the thinking part. So think about what kids are doing in this activity. And I go back to what Mr. Choi was saying just a second ago, right? In this activity, the secret slope activity, the first thing the kids had to do was explore. They got a chance to just play with it. And then they observe what was going on. They make some conjectures. They test themselves to see, was I right? Is my hypothesis correct? This is the scientific method, folks. This is exactly what scientists do. Then they revise their thinking and ultimately draw conclusions. Basically, they play, they notice, they formulate the hypothesis, they check, they adjust and modify, and then they generalize. They go, okay, I now know a rule. So this is an illustration of what Teaching 3.0 could look like. And it doesn't mean changing your curriculum. It just means taking whatever curriculum you're teaching the kids, and instead of, and I appreciate Mr. Choi for saying this, instead of giving them the formula up front, you save that for last. You make them get to it by saying, all right, I want you to observe some things. Observe some patterns. It could be static, it could be electronic, it could be digital. It doesn't matter. Just observe, notice. What do you think? What do you notice? What do you wonder? Formulate a conjecture. There's no wrong answer here. It's what you think, right? And then let's test it. Let's see who's right. So one way to do this easily is, you know what the answer is, right? You're the teacher, you already know what the answer is, but you ask the kids, look at the problem. What do you know is an answer that is out of the question? It just can't be. You already know. It's too small or too big. Now the kids already have a starting point. They know it can't be negative, for example, or the answer cannot be bigger than 1 million. You begin to zero in just by that conversation alone, as opposed to what is the answer. Begin by saying what do you know cannot be the answer. So that's just another quick way to get started. So some key features of Teaching 3.0, and I'm mindful of our time, and this is a very brief overview. The key features are, we shift the focus. Instead of just focusing on the answer, we think about, how do we get to an answer? It's a journey, not the destination. How do we get there? I can tell you the answer. One of the things I do with my kids when I was teaching high school was I would tell the kids the answer. I would say, hey, I'm going to give you some answers. Problem 1, answer is 12. Problem 2, the answer is 7. Problem 3, the answer is -5. Your job is to write me an equation where those are the answers. Now they go home and they can't cheat, because they're going to have to come up with their own equations. And no two equations can be the same. So if you call your friend, that's great. I would love that you call your friend, but your equations have to be different. So same answer, different equations. This is how you beat the cheat. You know, during the pandemic, kids were sharing answers every day. You know that because they think it's about the answer. But if you switch it around and just say, hey, I'm going to give you the answer, you tell me the problem. That is where the critical thinking begins to really, really take place. And they can't cheat on that one. So we shift the focus. Number 2, we focus on relationships, not just relationships between us and the kids, but relationships of the quantities. How are they related? It's a way of analyzing the problem. What's happening here? Not a mechanical procedure of, okay, every time you see this, you circle it, and then you do the close 3 read, and you do this. It's more about, how are they related? There are 2 numbers here. What's the relationship between them? Is one of them bigger? Is one of them smaller? Do they change? Do they change by the same amount? Is there a ratio? Is there a factor that connects them? So the kids are analyzing relationships. That's way more powerful than memorizing procedures. And really learning to use math rather than just solve a bunch of math problems. And lastly, provide a purpose for the procedure, right? Make them wonder what's going on here and help them see the situation and develop that love, the one that you just mentioned a few minutes ago. Because it's when they see the aha and their light bulb goes on and they make the noticings and they discover, oh my gosh, I see something. That's when the love for math begins. Think about your own journey and what makes you love math and what makes you appreciate the beauty, the symmetry, the relationships, right? That's really what we are aiming for. I have one more activity that I want you to look at, but we don't have enough time to really get into it. So this last activity I didn't develop it. It was from some folks in my class, my master's class at CSUN. I just appreciate it so much. They took a topic of rational functions and they wrapped it into something that the kids can actually care about, something relevant to their current life today. I'm not going to get into it, but I just want you to take a moment to look at it just to see how this lesson could motivate the kids to wonder, to ask questions, to say, well, what's going on here? Not just with the math, but the math becomes the tool for their analysis. So go to that and look at it. And I do want to make sure we wrap it up in just a second here. So I'll give you a couple minutes just to glance at it.
Is there a video at the start of that one?
Oh, you know what? The video got disconnected. I will add the video link. So you can skip the video. It's just a short video about healthcare in America right now. It's actually on one of my windows, but yeah, let me see if I can find it, and now I will put it in chat for you. So I got to stop sharing because I have to go to my window. I apologize that the link to the video got disconnected. Let's see if I can find it real quick. Yeah, here it is. It's a YouTube video. Let me put it in the chat here. But we're not going to have time today to actually dive deeply into this activity, just so you can see the structure, and eventually it gets to the math, right? But the kids get really into it because healthcare is a big deal right now, and with people being sick and all of that. So this grabbed the kids. They were thinking, we're not even doing math. We're just talking about something relevant to our lives at this point. But then eventually it gets to the analysis of what's happening and using math as a way to see the world. All right, let me get back to the, so I do want to move on, but here's another activity that you can take a look at to see how teaching 3.0 can motivate kids, right? At the end of the day, this is what I always focus on as a teacher to make my life easier. You don't want more complexity in your life, and you don't want the kids to see math as more complex than it needs to be. I always come down to these three ideas. Math is about quantities. I don't care if we're talking about complex numbers, we're talking about vectors, we're talking about, derivatives. Math is about quantities, relationships, and the representations of those quantities and relationships. So quantities involve things like magnitude, how big, how many, and position, right? Where, what direction. Even complex numbers, if you have been looking at some of the recent, or you already know this, right? There are people who are calling it lateral numbers rather than imaginary numbers, because there's a series of videos that's really fascinating about complex numbers, but it's about position and magnitude at the end of the day. Relationships deal with the connections between the quantities. How are they related? Where's the maximum? Where's the minimum, et cetera, right? And then finally, the way we represent them. We use graphs, we use tables, we use charts, we use equations, we use symbols. The big sigma symbol is a symbol that to us means the sum. And then we put this little thing below it, like from I equals 1, it's a counter to k, some number k, and that sigma notation tells us that the incrementation of I is by natural numbers, are 1, 2, 3, 4. So those are all accepted symbology that we come to know. I just want to say that symbols themselves are not sacred. They're invented. We invented them here on this planet to convey ideas. And I can guarantee you that Jupiterians on Jupiter don't use the same symbols. So, but they have the same ideas. And that's the main point here, is that let's make sure that the kids focus on understanding quantities and relationships, and always circle back. How are they related? What are the quantities involved here? How are they related? The symbols are just ways that we express those quantities and relationships. So with that in mind, the last piece of the puzzle is to embed culturally and linguistically relevant contexts, right? We want to, I call this clear, culturally, linguistically relevant and responsive. We just want to help make our lessons clear, because it really gets away from this idea of simply what works, but what works for whom. You got to think about your kids. Who are they? And relate it back to where they're coming from. Then they'll buy in. Then the kids will get into it. At least more kids than maybe currently right now. And I just want to say, if you think back to that first lesson, and I'm so glad, I think Jeff was the one that noticed this, Jeffrey, the contrived context of going to a family picnic doesn't equal cultural relevance. That doesn't do anything. I've seen teachers do this. They throw in something that has nothing to do with the problem, and they say, well, it's culturally relevant because I, tied it in. At the end of the day, it's empowerment that makes the difference. And empowerment equals voice and agency, meaning giving kids the chance to notice and to talk and to share. And I love Carmen for sharing that first activity today with which one doesn't belong, because that's what gives kids voice. That's what helps them develop agency and a sense of, I can do this. Right now, a lot of kids feel like they can't do this because they've been told or it's been reinforced that somebody else is the mathematician. But you want the kids to all feel like, I can do this. I have something to contribute. I have an opinion. I have some observations I can make. I can notice. And if it's wrong, that's fine. Change your opinion. That is perfectly okay. This is what we do. This is what scientists do. They hypothesize, they check it. Nope, that wasn't it. Try again. When we play games, video games, it's the same thing. Kids, Angry Birds, remember that from a few years ago? You launch the bird. If that didn't hit the target, you change the angle. That was perfectly acceptable. No one was judged. No one felt shameful. So what we want to do is to empower the kids using this simple set of strategies right there. No extra work, just giving kids the chance to play first. So give them the problem and have them say, this is what I do with my kids when I taught AP Calc. I said, just draw something, illustrate it, write something down, explore, see what happens, see if it works, see if it doesn't work, do something, as opposed to wait for somebody to tell you the method, because I'm not concerned about the method. I'm concerned about you making sense of what's going on. And that's the starting point for equity in teaching. Now, in just the seconds I have left, I want to share with you a couple of results. Otilia mentioned this at the outset, and I just did, I finished up a big $3 million federal grant researching this. So, and plus some prior grants, and Philip is already familiar with this. Some years ago, when I was still teaching at San Fernando High School, SFHS, when we were still giving the district benchmark, if any of you are old enough to have been there for that, and we had some data from this work that I was doing, and the kids that were in my group, I wasn't their teacher, but the teachers I worked with who used some of these strategies that I just shared, you can see compared to the blue group, which is the rest of the school, how much better the kids did. Simultaneously, back then with the CSTs, LA Unified had this percentage of kids either basic, proficient, or advanced, right? You remember back in those days. And the school was slightly below the district. So the 300 kids that were randomly selected, well, they were not so random. They were the lowest 300 kids of the school. We worked with the lowest kids. So the classes that were the most remedial, the kids had failed before. In fact, I think that's the common denominator. Every student in this algebra class had failed at least once, some multiple times. So that was the population. And now, 1 year later, the school, you'll notice, didn't change. The district went up a little bit, but the school is still the same distribution, the same total percentage of kids that were basic, proficient, or advanced. Now, the 300 kids I was just mentioning, there they are. Using the same strategies that I just described, those kids really jumped, okay? And then here's a different project, and you can see in 1 year, the red trend close the gap between the district and the native population of the schools that I was working with. So that subgroup went up dramatically, and at the end even exceeded the district. And this is the final, this is work I did up north at a different school. This is the project that Otilia alluded to, and this is where I'll finish. The treatment group outperformed the control group. We had, it was a statistically significant impact, randomized controlled trial, just like Pfizer and Moderna. It was randomized. We had 7,200 kids from across the state in 9 different districts, LA Unified being one of them. So clearly the treatment outperformed the control. And then our second group of treatment also outperformed control. But here's the part that I want to end with. We disaggregated the data between English learners and English proficient kids. And so in the control group, you can see English proficient outperformed English learners. No surprise. Here's what happened with our groups. Our English proficient kids clearly did better. But look at this now. This is what, hold on to your seats. Our English learners outperformed English proficient kids in the state. 7,200 kids, random selection. Our English learner kids, that's the median score, was higher than English proficient kids. Even with the error bars, this is like a box and whisker plot, it was still higher. What made the difference was these strategies, these equity strategies that I just shared with you. Simple strategies, no extra work. And that's what made the difference. And I think we can do it together. We can make a huge difference with our kids in LA. Thank you.
Thank you so much, Ivan. That